All right, ladies and gentlemen, in this lesson we're going to introduce what is a very simple idea. In fact, it's an idea that you've been using to solve equations ever since you knew how to solve for x. So we're going to introduce this idea and then introduce some more challenging notation that goes with this idea so we can talk about it in a more rigorous way. So to introduce this idea, we're going to talk about going to see a writer's block show, so make sure you've read the prompt here so you know what we're talking about. In question 1, we're asked to write an equation that gives the cost D of going to the show if you order Z ounces of ice cream. So, well, it's a $5 fee, and then plus, 40 cents per ounce, so 0.4 times Z. And then if your cup weighs 14 ounces, well, that's Z ounces of ice cream, right? How much would you pay in total? Well, obviously here we're plugging in 14 to our equation, right? So that would look like this. And when you evaluate that, I'm just using my calculator, you get $10.60, which is not bad for an evening of ice cream and poetry. Okay, now we're given the opposite, and here's where we start to build towards the idea that we want to study here. So we're bringing $10, so we have D equals 10 now. And notice that we're now solving for Z, so we have an equation to solve instead of just plugging something in to evaluate. So there's my equation, and again, I'm just evaluating this last step in my calculator. And I get 12.5 ounces. So notice these are kind of the opposite problem, and that's really the idea we're building towards. Now here, we're asked to write an equation that gives you the number of ounces of ice cream Z you can buy if you bring D dollars, right? So we want an equation that's like solved for Z. And notice that's the opposite of this equation here. So here, I'm going to start with just my equation. I'm going to do the exact same thing that I did before. So I'm going to get D minus 5, subtract 5 on both sides, equals 0.4Z. And then I'm going to divide by that 0.4. So I'm going to get D minus 5 over 0.4 is equal to Z. That's going to be my equation. So I would say that's the opposite equation of my equation for D, right? Just like question 2 and question 3 were kind of the opposite types of questions. And then for question 5, right? I'm given that somebody is buying 10 ounces of ice cream and I'm asked to find the cost. And it's like, the question is, which equation should I use? Well, obviously I should use the equation that's already solved for me, right? It's just going to be easier. And that's very clearly going to be Henry spending $9. And then Chandler, I guess these guys are from Friends, is spending $9, and I'm asked to figure out how would I determine how much his ice cream was, right? Well, here I should use my equation Z because I'm solving for Z, right? It's already done for me. So it would be 9 minus 5, and then over 0.4, which also, of course, gives you 10 ounces. Okay, so what we're building towards obviously is this idea that like my equation for number 1 and my equation for number 3 are opposites, right? Or sorry, number 4, they're opposites. Now, here is where we introduce the new notation to represent that, right? So the notation is for this idea of an inverse function, right? So my function, my original function is f of z, right? So it's a function that depends on z, is equal to 5 plus 0.4 times z, right? So it's a linear function. So again, the ideas we're working with are not that complicated. We're just introducing new notation here. Now, the new notation is, how do I represent that I have this function that is the exact opposite of this, right? Well, we've seen this before when we were working with our trig functions. I just put this -1 here. And we read this as f inverse, and it just means the opposite of f, right? So I would say f inverse in this context of D. Well, f inverse was my equation for Z, right? So it would be of D minus 5 over 0.4. Okay? So the way I read this, just so you sound scholarly, is f inverse of D, and then it's important to note that it's the opposite of f of Z. And when we say opposite, that really means what it has always meant for us in mathematics, which is like they undo each other. So let's investigate that here with question 7. So f inverse of f of x. We're missing a parentheses there. So f inverse of f of x, right? So this means plug in one into the other. It's a composition of functions. So this means f inverse of f, which means then we want to plug that into our f inverse here, which would be 5 plus 0.4x minus 5 over 0.4. So notice I took my d here and I plugged in 5 plus 0.4x. And then look what happens here. Well, these cancel, right? And then these cancel. And just x is left over, right? So the key understanding here really, that if two functions are inverses, they undo each other, right? So plugging one into the other cancels them out and leaves us with just x here. So when you're solving an equation, right, for like x equals whatever, you're using inverse operations. This is that idea still, right? We're just introducing notation to represent it in terms of functions. Now, let's consider what the graphs of these things look like. So what I've done is I've just graphed both of these on our calculator. We have f of z in red, and notice that has the y-intercept of 5, right? So I'm just going to sketch that graph here. So the y-intercept was 5, and my slope is less than 1. I'm not going to be super precise about drawing it, though. And then here, my y-intercept is negative for my f inverse function, but my x-intercept is 5. And that makes a lot of sense, right? That my x-intercept for my inverse would be my y-intercept for my original function, right? So I'm going to draw it that way as well. And again, I'm not going to be super precise, but notice my slope is a lot steeper, right? So I'm going to draw my x-intercept, and I'm going to draw it going up here. And that is f inverse of d. And to label our axes, well, z is ice cream in ounces. And then my y-axis, f, is dollars, right? And then here it's the exact opposite. So this is ounces of ice cream, and here is dollars, right? So input is dollars, output is ice cream, and then up here it's the opposite. And then let's note our intercepts here. What's interesting, if I look at the graph, right, is that these are reflected over each other, right? So notice, if I add a third line, which is y equals x, that line kind of cuts our picture perfectly in two. So they're flipped over this line. And that's true of all inverses. So what we're asked to consider in number 8 is if we have f of x equals x squared, which we definitely know is a happy parabola. We can do better than that. Why does it have no inverse function? And let's imagine we drew that line. So here is f of x. Imagine we reflected it the same way over the line, y equals x. It would look like this. This would be f inverse of x. But this is not a function, right? So the answer here is that the potential inverse is not a function, right? Because it has more than one y value for a given value of x. It fails to pass the vertical line test. Okay, I'm going to give you some definitions that we're going to investigate. The first is this idea of an inverse function undoing a function. So inverse function just means the opposite. That means f inverse of f of x is equal to x. So those kind of cancel each other out, right? And then this idea of one-to-one. So a one-to-one function is something like our linear function. This function is one-to-one, whereas our parabola is not one-to-one. And the reason it's not one-to-one is because I can draw a horizontal line that touches more than one part of the graph. So a given y goes with more than one x. So we talked about a vertical line test earlier. Here we have a horizontal line test. And the rest of this lesson is really going to be about investigating the relationship between these two ideas.